Hello and welcome to Slooh, and especially those of you joining us on our brand new 24-hour channel. We launched the channel earlier today, so whenever you visit slooh.com, you'll be able to enjoy the best of Slooh and live telescope views direct from our Canary Islands Observatory every night. Now, wherever you're watching from, make sure you're watching at the very best quality by hovering over the bottom right of the video and selecting the 720 high def setting if your bandwidth is good enough. Now, anyway, why are we here today? Just over 6 hours ago, an object, the size of a car, slammed into Earth's atmosphere. This mystery object was designated WT1190F when it was discovered in October, but has become more colloquially known as WTF. Now, as you know, that stands for what the flippin' heck. Sorry, I just wanted to do that because I wanted to see the expression on my producer's face. Now, this animation that we're looking at on the screen at the moment was created by Slooh member Tony Evans last week. He's the leader of Slooh's near-Earth asteroid monitoring team, who routinely track asteroids like Spooky, the Halloween asteroid we broadcast a couple of weeks ago as it whizzed by Earth. Now, Tony submitted these images and his measurements to what's called the Minor Planet Center, and that helped pin down WTF's orbit and the time and location of its re-entry this morning. Now, although we don't hear about it every day, impacts like this are not uncommon events. In fact, we believe around, I think it's 50 to 200 large man-made chunks of hardware survive their unceremonious return to Earth every year. And estimates have been made that over the last 4 decades, 12 million pounds of space junk has survived the trip through the atmosphere to hit the surface. However, what's rare really about this event is that we knew about it beforehand. Now, only 2 previous impacts by known objects have ever been observed. Asteroids 2008 TC3 and 2014 AA. Now, Slooh members were among only a handful of people who captured these images coming up of 2008 TC3 before it impacted the skies over Sudan in 2008. And asteroid 2014 AA was the first asteroid discovered in 2014, only a day before it crashed into Earth's atmosphere somewhere over the Atlantic Ocean on New Year's Day 2014. Now, we would have loved to have brought you live images of WTF impacting the atmosphere this morning, but because it's so difficult to predict how an object will interact with the atmosphere, it's not possible to set up live feeds of the re-entry in the same way that we do. Now, I am being told, this is the very first image of WTF as it impacted Earth's atmosphere to the south of Sri Lanka this morning. Now, we were hoping to have a member of the mission team. So let me go back a sec, because that is the first time I've ever seen this image. And in fact, we believe this is the first time anybody has seen this image of impact over the skies of Sri Lanka. Now, what I was going to say was it's been impossible to observe it from the ground because the whole region has been clouded out. But a special team was set up, and they went up in their Gulfstream jet earlier this morning to observe it above the skies. They had a whole stack of different and specialist cameras to be able to grab this, and we were hoping to have a member of the team join us in the show, but my producers just told me that he's caught up in a press conference, but he was able to send us these images beforehand. So wow, and there are images of the team. We were hoping to have Stefan Lowell join us. So this is on their special Gulfstream jet, which flew from Abu Dhabi this morning, and you can see some of those specialist cameras. Those guys were the only people able to see WTF with their naked eyes, as well as through all of these special cameras, which are telling us a whole stack of things. It's even telling us, one of the instruments is telling us what it was made of. But you've seen it here first. Thankfully, Stefan sent us that image, so we'll call that up in a second. But while a piece of space debris causing a fireball like that in the sky may seem like a fitting event for what some people think is usually an unlucky day, this event is actually extremely lucky for those hoping to study the effects um, of the atmosphere on objects slamming into it like this. So, to understand more about WTF and why it's important for scientists, I'm joined now by Dr. Mark Boslow, long time friend of Slooh and an expert in impact events. Welcome, Mark. What do you make of these images?
Good morning. Well, this is fantastic. This is the first I've seen them. And after looking at my Twitter feed last night after the event and seeing a bunch of negative observations, nobody saw anything from the ground. I had kind of lost hope. I went to bed, so I'm delighted to see that this team was actually able to record something, and these look like great photographs. They're going to be very
They do.
useful. This is great.
It is. And one of the other things, of course, that made this object so difficult to observe this morning is that it happened near midday local time. So that's what this thing looked like in daylight skies. So even better. Now, Mark, let's take a step back. I mean, this is great. This is the first time that anyone has seen, other than the team, these images that they took earlier today. Sorry, I keep getting a bit distracted when a new image comes up. But let's take a step back. Uh, and let's start with the basic. What is space junk?
Well, so space junk can be anything artificial. I wouldn't classify an asteroid as space junk. Those are natural
No.
objects, and this wasn't an asteroid. This was some artificial object, part of a spacecraft. I don't think we know yet what it was. I'm hoping that they got some spectroscopy successfully collected
They did.
the
Yeah.
spectrum of this thing, which will give us another clue about what material it was made out of. So there may be enough clues in this to actually backtrack and determine what it came from, what it really was. It was probably
Um,
a moon mission. There were
mm,
a lot of moon missions, so it could be a piece of an Apollo spacecraft. It could be a Chinese mission. It could be an unmanned mission to the moon. There are a lot of possibilities. It
and
wasn't a
what we're
very
seeing
big,
at the
it wasn't a
moment,
very big
sorry,
object as far as I can tell.
sorry, Mark, just to interrupt, what we're seeing on the screen at the moment is an animation of the known space junk, which is being tracked by all manner of organizations. In fact, the military are some of the biggest trackers of space junk. So this is old satellites which have, they've run out of power or propellant, but still orbiting. They're smashed up pieces of man-made rockets or all manner of other man-made objects, and you can see an absolute swarm around the earth, and we can see that close up, that sphere of these objects very close to earth, which is low earth orbit where a lot of the satellites are. But what do we know about this one? This was discovered uh, in October, I believe, by Rose Matheny of the Catalina Sky Survey. What else do we
Right.
know about this particular piece of space junk?
Well, it was, I think, rediscovered. It was an object that had been discovered before and lost because it was in a very eccentric orbit. It was in a very elongated orbit that took it way out beyond the orbit of the moon, and it was small. So it spent most of its time at a very large distance. Unlike what you just showed, most of those were in low Earth orbit. They're easily
Yeah.
observable from the ground. There were a lot. You could see a ring in what you just showed of objects in what looks like geosynchronous orbit. There was an equatorial ring of stuff. And this wasn't in either one of those categories. This was in a
Yeah.
very elongated elliptical orbit that took it way out beyond the moon, where it just drifted and then fell back periodically. And so it could only be observed really when it was close, fairly close to the Earth, when it was moving very fast. And until its orbit was well established, it would get lost. And so I
Yeah.
think it was rediscovered on October 3rd, and then it was, you know, uh, its orbit was calculated and shown that it had actually been observed before, and maybe back as early as 2009.
That's
And
right.
then
I
it
mean,
was
it wasn't
extrapolated.
only
I'm
that they think that it's been discovered twice before, don't they? Before this latest reacquisition, and so much.
right,
You know, this is the story on asteroids, near Earth asteroids as well. So many get discovered, but then
right.
get lost again, which is why it's so important that people
Yeah,
like
there's
Slooh
not
members
enough.
actually
Yeah, there's
track
not
these
enough.
objects.
The observational arc is not long enough to extrapolate forward in time until it comes back close enough to be visible again to uniquely identify. And I think that was the case for this object. But then
Yeah.
it was this time around, it was extrapolated forward and found that the perigee, the point of that it was closest to the Earth was actually inside the Earth, which means it was an impacting object, and so
And
here it
here we
is.
see once again one of these fabulous images from the team who went up above the clouds in a Gulfstream business jet with their special cameras. And this thing, Mark, was, I mean, it was traveling at some 24,600 miles an hour, 11 kilometers a second. Extraordinary speed. And you talked about this very elliptical, long elliptical orbit that it had around the Earth. And that is why we currently believe our best guess is that it is part of a rocket or fuel motor, part of the fuel tank of one of the rockets that was sent up, possibly even from one of the Apollo missions in the 60s. Is it those two pieces of information which is giving us our best steer that it is a part of a rocket?
Well, I think the orbit that it was in is consistent with that. They're not that many missions that would leave space debris in an orbit like that that would take it out beyond the moon. As your animation showed, most of them are in low Earth orbit because that's where we put most of our satellites, or in
Yeah.
geosynchronous orbit. There aren't that many things we launch into orbits that would take them beyond the moon. So it's most likely a piece of a lunar mission. Now, my understanding is that it's probably not that massive. In
Yeah.
this image, it looks like, well, this must have been a pretty big thing. But remember, it's coming in at 24,000 miles an hour, and there's a lot of
Yeah.
kinetic energy. Every kilogram of material has about the same amount of energy as 10 kilograms of high explosive when it's moving that fast. So when it
Just
hits the
repeat that for us,
atmosphere,
Mark. Could you just repeat that one fact? Every kilogram of space junk entering the atmosphere at this kind of speed is equivalent to how much?
about 10 kilograms of high explosive of the
Wow.
TNT. And that's just because it's moving so fast. It's got, you can calculate the kinetic energy, and the kinetic energy density is, greater than the mass. And when you measure it, we often put things in terms of kilograms or kilotons of TNT. For something this size, it would be kilograms of TNT. So it could be, it was probably less than a ton, almost
Yeah.
certainly less than a ton based on the size. Now, the size was based on deviations of its orbit due to solar radiation pressure. This is my understanding, is that they have to do, when orbital dynamicists calculate the orbit, it's not perfectly Keplerian. It's
Mm.
not just purely gravitational forces on this thing. It's small enough and it's got a large enough surface area that light is actually pushing it around,
Yeah.
providing a little bit of force and causing it to deviate from the course that it would otherwise have. And you can solve for the difference. So you can calculate where it would be without that, and then add it, and that depends on the surface area and density. And they come up with a very low density for this, and then the size is based um, on the magnitude, the brightness of this thing, assuming
Yeah.
some reasonable albedo or reflectivity. And that's down around on the order of a meter or two. So it could be as
Mm.
small as my bed sheet, you know. I mean, my bed
Yeah.
sheet isn't very massive, but it would be this bright if it were spread out and floating in space. It could be
Yeah,
seen.
I mean, so
Uh,
what you're
in,
talking about here is, this is why this particular event has been so important to scientists, isn't it? Because it enables us to understand things about the solar radiation pressure, so the
yeah,
force of the
yeah.
sun's, energy coming off, how it affects an object like this, and it's also.
I just lost you, and I don't know if it's me.
Hello, I think we are back.
Oh,
Hello, Mark. I'm sorry about that. You lost me for a bit. Let me hasten to add to viewers out there that was not caused by this piece of space junk called WTF entering Earth's atmosphere this morning. Now, I was just saying hello to Justin and his astronomy class who are watching the live show this morning. Now, we were talking about the intense speed of this thing and what we can learn about it, Mark. Now, you mentioned right at the very beginning that maybe the team who took these wonderful images, these are the first time these images have been seen publicly, um, from their Gulfstream jet over the skies of Sri Lanka. You said that they maybe had an instrument on board which would be able to measure what this is actually made of. What was that about?
oh, well, I think they have a spectrometer. My understanding is that they also were going to try to do some spectroscopy, and that is a method. Basically, you know, white light consists of light of different colors, and different chemical species emit different line spectra. So, like for example, sodium, you know, has the famous yellow twin yellow emission lines. And so different metals have different emission lines that are like fingerprints for that particular metal. And so if they can if they can get a good spectrum of this, they can get some idea of what it is made out of. So, for example, space debris would probably have a lot of aluminum, titanium,
Yeah.
those lightweight, strong metals that they make spacecraft out of, probably silicon, other things. So it will be interesting, and that might help identify what it came from.
Absolutely. I believe the team as we're seeing them here. These are images of their special flight this morning. This is
Yeah.
a combined mission by the United Arab Emirates Space Agency and the European Space Agency. They're collecting this data now. I would just like to go back to one of the images that they gathered, because we're talking about the color, being able to say what it was potentially made of. And actually, we can see in those images that they collected, the different parts of the debris, the bits of the firework, are actually burning with a slightly different color each one. So maybe that's what we're even seeing in that, the old chemistry experiment in class where you burn different metals and you see the flame change a different color. I certainly saw some oranges and some greens in those images, when we can get those back up again. Now, Mark, you study impacts, predominantly asteroid impacts and the effects of that. What danger does space junk pose to Earth? We've seen these images. Most of it's burning up in the atmosphere there. Does it ever actually get through to make contact with the Earth's surface?
Well, yeah. In fact, when Skylab came down, solid pieces made it to the surface. When Mir, the space station, came down, the same thing. Occasionally, a satellite in low Earth orbit, parts of it make it all the way to the surface. Now, when something re-enters from a low Earth orbit, it doesn't come in at this steep of an angle. It comes in at a very, very shallow grazing angle, and
Right.
it's coming in slower, but it's got more time to burn up. Um, and so things tend to burn up, at least the small, thin fairing panels and things like that tend to completely ablate away.
Mm,
But yeah, when a big piece of this stuff falls out of the sky, if it falls in a place where people are, it's a risk, it's a danger.
yeah.
Fortunately, most of the Earth, as populated as the Earth is, most of it is still uninhabited.
Yeah, and most
And
of it obviously is ocean as well. Now, it's not just for people on Earth who these things, you know,
yeah,
albeit a small risk. The people in space station. I mean, this is space junk is a very real danger to them, isn't it?
absolutely, yes. So the International Space Station is very much at risk from orbital debris, and even very tiny pieces of orbital debris can poke a hole in it. And of course, that would be catastrophic if
Yeah,
it actually penetrated the life support system and let the air out, or damaged life support. That's a very real risk, and there's
yeah,
many more of those little tiny pieces that would never make it to the ground. Those are
yeah.
re-entering all the time. Um,
Mm.
those aren't a risk to people on the surface, but they're definitely a risk to operations in low Earth orbit.
Yeah. Yeah, I mean, it's part of that 12 million pounds of, estimated space junk that has actually impacted over the last 40 years.
Right.
Now, we were talking about the risks of the space station. I believe it was only a few weeks ago that I saw a notice that the entire crew had to get themselves ready in their emergency Soyuz capsule. I think it was a Soyuz capsule, because there was a piece of space junk that was on a potential trajectory. And we've already explained it's the speed of this. It can be really quite small, but the velocity that these small bits of
Right.
metal or whatever are traveling at mean that they
Yeah.
contain huge amounts of energy. Now, Mark, we've got a Twitter question for you. You can always
Okay.
ask questions here at hashtag Slooh. But the question is, what's the likelihood of space junk hitting the US?
Oh boy, I don't think I can put a number on that, but it's very high. I mean, it depends on over what time interval and how big a
Yeah.
piece of space junk is. But I'd say the likelihood is 100% that a piece of space junk is going to hit the United States. It happens all the time. Generally, the pieces are too small to do any damage. But yes, I mean it can happen all the time.
Right. Okay. Well, thank you for that, Mark. Thank you so much for joining us as we
Sure.
look at this. The first time these images have been seen of WTF as it entered the
Yeah.
atmosphere this morning. Thank you very much, and we'll hopefully see you back at Slooh soon.
Okay,
Thank you,
we'll
Mark.
hope something like this, some harmless event happens again, and this uh, group called the Next TC3 Consortium that ran the Gulf Stream
Mm,
experiments. I first heard about this last summer. I saw a talk by Peter Yeniskins out at NASA Ames Research Center. I was very excited. I didn't expect them to actually get to do it so soon.
no,
So I'm really
no,
happy
it's
for
it's excellent. So
them.
thank you very much, Mark. We'll see you back here at Slooh very soon.
Okay, thank you.
As Thank you. As Mark was saying there, it was that consortium who was set up actually. That team, the TC3 consortium, were put together to try and locate pieces of the asteroid that impacted over the Sudanese desert in 2008. Slooh members were the first to get images of that asteroid just before it impacted Earth. And here we are again. We were looking at those. There it is, and you can see those little dots, those coloured lines. That's this asteroid 2008 TC3, just hours before it impacted over the Nubian desert in Sudan, and that was captured by Slooh members using the Canary Islands Observatory, the robotic observatories that Slooh members get to control every night. Now, what have we got coming up? Well, I would just like to say there's an event next week that you mustn't miss. It's going to be live coverage of the peak of the Leonid meteor shower. So Tuesday the 17th, that's the night of Tuesday the 17th. And we have got loads of partners set up to give us live views of those meteors. If you're lucky enough, by the way, we'll have the Weather Network as well. Scott Sutherland from the Weather Network. Keep an eye open on our Twitter and Facebook feeds. He's going to be giving us live weather updates so you can plan your own Leonid meteor watch evening. And if you're lucky enough to have clear skies, join us, take your laptop outside or your mobile device outside and use us as the soundtrack as we explain everything you need to know about Leonids. So come back next Tuesday. We have also launched our 24-hour channel today. We're really excited about that, where members can watch the very best of Slooh over the years, but also every clear night, live telescope views of stunning objects. So if you're a member, make sure you check out the new 24-hour show. And I would just like to say we've heard that Justin is watching with his astronomy class. Well, over the last couple of days at the National Science Teachers Association, we have launched Slooh Classroom. That's our new initiative to bring live astronomy into classrooms. Loads of lesson plans already created for teachers there. The kids get to use the robotic telescopes in the Canary Islands. Well, this is rather a fitting image, I think, to finish the show on. We've been able to show you the very first images that were taken of WTF, this piece of space junk which slammed into Earth's atmosphere this morning. Huge thanks to the team who couldn't unfortunately join us during the show because they were in a press conference actually showing these images to the press, but we were able to bring it to you live this morning. So thank you very much for joining us here at Slooh. Enjoy these images and we will keep you updated on the Slooh Facebook and Twitter feeds if we find out any more about this particular event. Goodbye for now.